Up to now, you've seen identity, signatures, and trust services in pieces. In this module, we'll stitch them together into one working system. Imagine following a customer click by click and being able to point to exactly which component handles every step. Here's the path we'll take. We start with the foundations: digital identity, trust, and eIDAS basics. Then we place them in a banking and user experience context. After that, we unpack the key technical components. And finally, we combine business logic, UX, identity, signing, and evidence into one traceable blueprint. The story we'll follow covers the full life cycle of a banking onboarding case. A customer enters a channel like web or mobile and shares basic data. We then proof their identity and run risk checks to decide whether to continue. Next, the bank prepares the contract and triggers strong authentication, plus the qualified electronic signature. Only after all legal and technical evidence is captured is the new bank account actually activated. The journey really begins when the customer first lands in the digital channel, web, or mobile. Even before we ask for identity data, the bank quietly builds a risk picture around the device and network. TLS secures the connection. Device fingerprinting links this browser or phone to past behavior, and IP reputation flags suspicious locations or proxies. From these signals, the onboarding backend can create a provisional user record and decide whether to add extra friction to the flow. Once the customer enters their personal data, the bank immediately uses it for automated pre-checks. That information is screened against sanctions and PEP lists to spot higher-risk customers early. In parallel, basic eligibility is evaluated: age, residency, permitted products, and simple rule-based risk filters. These checks don't yet prove identity, but they remove obviously non-compliant cases and route others into different onboarding paths that the orchestration layer will handle later. For actual identity proofing, the bank doesn't do the heavy lifting itself. It delegates that job to trusted external identity providers, such as national eID schemes or certified remote proofing services. The eIDAS node acts like a broker. It standardizes the request, forwards it to the right provider, and returns a clear result: verified identity attributes, an assurance level, and a package of proofing evidence that can be stored for audit and compliance. With the user's identity data and proofing results in place, the bank feeds them into several decision engines. Typical ones are AML screening, fraud detection, and credit risk. Each engine contributes to an overall decision matrix. If the combined outcome is positive, the customer is automatically approved. If something is unclear or risky, the case goes to manual review, and in high-risk situations, the application is declined. Every decision is logged so it can be traced back to the underlying evidence. Next, the bank assembles the actual signature transaction. Two ingredients come together: the final contract PDF from core banking and the customer's verified identity and product details from onboarding. These are packaged into a single signing request object. That object clearly states who is signing, what they're signing, and under which context. Only then is it sent over the signature orchestration API to start the qualified signing session. At this stage, the user has already been strongly authenticated and has given explicit consent. That proof is sent to the qualified trust service provider, which controls the user's private signing key inside a hardware security module. The QTSP platform combines the protected key, the user's certificate, and the document hash to generate the qualified electronic signature. The result is a PDF that now carries a legally binding QES, enforceable like a handwritten signature across the EU. With the contract signed, the bank must be able to prove, even years later, exactly what happened. So it bundles three elements: the signed document, the cryptographic validation report with trusted timestamps, and detailed transaction logs, including IP, device, and consent evidence. All of this is written into a tamper-evident, time-stamped repository. Architecturally, treat this as a core compliance service, not just file storage. Other systems will rely on it for audits and disputes. Now everything we designed comes together. After the qualified signature is validated, the bank can safely create the customer profile in core banking, link it to KYC records, and set product parameters like limits and channel access. Next, digital credentials are issued: login methods, strong authentication mechanisms, and possibly payment instruments. Finally, the customer signs in using those credentials, showing that the end-to-end, eIDAS-aligned onboarding loop is closed and operational. You can think of this architecture as 5 stacked responsibilities. At the top, channels handle how customers interact: web, mobile, or contact center. Below that, the integration layer hides complexity with APIs and orchestration. Business services implement onboarding, risk checks, and customer management. Trust services form your eIDAS core, identity proofing, remote qualified signing, and evidence storage. At the bottom, core systems like core banking, CRM, and document management actually hold and process the money and records. When you design an eIDAS solution, define your trust lines first, then your components. Inside the bank network, systems can communicate more freely, but the moment data crosses towards an eIDAS node or a qualified trust service provider, the rules tighten. Every crossing needs encryption in transit, strong mutual authentication, and a contract that defines responsibilities. If you can't clearly state those protections for a given connection, that integration isn't ready for production. Traceability means proving that every design choice answers a real requirement and mitigates a concrete risk. Remote KYC exists to reduce identity fraud, so we implement strong identity proofing APIs or eID integration. Legally binding contracts raise the risk of repudiation, so we rely on a remote qualified signing service and HSM-backed keys. Supervisory audits target compliance failures, so we design a tamper-evident evidence repository to preserve the full story. Your eIDAS banking solution blueprint is now coherent end-to-end. The onboarding journey is coordinated from first click to core banking. System boundaries to external trust services are clearly defined, and every component is traceable back to a concrete business rule or regulatory requirement, giving you a design that is both operationally sound and defensible.